Good morning, good afternoon, good evening, everyone. How is my sound?
Good.
Okay.
Good.
Lots of people are popping in like crazy, so we will start shortly. Welcome to the third and last session of the research papers. Today's theme is going to be materiality and environmentalism. And we have a wonderful selection of papers from Chile, Peru, Brazil. And you will have 10 minutes and Peter will operate the sound effects so that you know when you are coming to the end. And then we will have time for one question. Okay, so I can see that some of our presenters are already here, so I would like to start with the paper which is called Design and Robot Assisted Carpentry Joints for Wooden Houses, and Michelle Ramirez will be presenting, and I think you should be able to share your screen, Michelle.
Hi, Cindy.
Hello, welcome.
Thank you. Can you see my screen?
Yes, perfectly.
Okay. Hello, everyone. My name is Michelle Ramirez, and I am architect from Chile. And I will present the paper Design and Robot Assist Carpentry Joint for Wooden Houses. This study addressed the design of a traditional wooden structure of post and beam for a single-family house in Glulam of Douglas Fir, an Arab species ground in southern Chile based on robotized carpentry joints. The final objective was to design, analyze, and build a prefabricated structural system with carpentry joints for the optimization of the construction and assembly process through robotic mechanization and on-site assembly. With the correct execution of this project, it is expected not only to demonstrate an innovative, efficient, and sustainable way to conceive a structural system, but also to promote and disseminate in Chile the use of timber as construction and structural building material, robot assist, and industrialized with innovative technologies. The structural system proposed in this research is designed to prefabricated and modular, reducing the carbon footprint in the use of machinery, less pollution when prefabricated, and less in situ pollution at the time of construction or assembly. These two, the lesser use of steel in the structure, also reducing the total cost, and through a national forest management from the origin to the manufacture of the good to be used. This research aims to be a contribution to the current developments intervening in the laminated good structure through machining process and joint designs, so that the robotic arm not only works as a fastener or linear milling machine, but also develops the use of its 6 axes with a structural objective and direct contribution to development of predefined elements such as steel connectors. The project corresponds to a 2-story prototype house of 73 square meters. It is founded on isolated reinforced concrete footing with customized steel connector in its 8 columns. The structural design is defined as a mixed construction system, which is composed of a primary post and beam structure and a secondary structure with a diaphragm of some timber trusses. This structure is defined as a heavy post and beam framing. The total amount of glue used was 11.85 cubic meters. This structure has robotized reinforcement carpentry joints and hidden steel connector in its transfer axis, both made with robotic process. There were 3 critical design points: the length of 60.3 meter longitudinal post beam joints, the length of 2.4 and 3 meter transverse post beam joints, and the post foundation joint. In addition, hidden connectors were established in the cross section in the foundation in such a way that they continue with the logic proposed for the RC system, providing a longer collapse time for the structure. The final design corresponds to a carpentry joints of mortise and tenon by steel dowels with a circular base. For the machining process, a prefabrication of 24 tenon in 12 beams and 24 mortise in 8 columns. These assemblies produced 4 transverse frames of the primary structure of the project. The mortise has a total depth of 190 mil, of which 60 mil go in, and the tenon 130 mil, to achieve a greater separation of the pins with the shoulder. Also, adding to the machining labor time was the cutting of the beams that received the steel connectors. For this, we used AutoCAD, Rhinoceros, Grasshopper, and the GH KUKA PRC plugin for trajectory simulation and direct transfer to the robotic arm. The tools: the bridge crane from the sawmill to transport and change the timber components within the working sector. The process took 9 days of machining with 8 hours per day for the 4 frames. Total pre-machining time, 443 hours. Programming time, 14 hours. Total process time, 523 hours. And the total working days time is 65 days of 8 hours per day. After being mechanized in Villarrica, the laminated wood was transported to Valparaíso to begin construction of the house. The house is for a family that lost their home in the fire on 2019, testing the versatility of adapting the structure to hilly site. To assemble the 4 structural frames, 9 construction workers were required. Each frame weighed 1 ton, making the transfer and movement of each quite complex. This frame included 2 posts and 3 beams of 60.3 meters. The wall precision was done manually, with the help of a cordless drill to insert the corresponding dowels in each joint. The assembly of the 4 frames was done horizontally to the ground to be hoisted and installed on the foundation connectors. The complete assembly process of the structural frames lasted 18 hours. For the primary structural lifting and installation took 10 hours, and resulting in a total of 28 hours of continuous work, spreading 3 working days with 9 construction workers on site and 1 loading crane. This is a contribution, and thank you very much.
Great, thank you. So we have a bit of time to take it out to the audience for a question. You can just unmute yourself or you can put it into the chat. Oh, I see a hand up. Digital Media Fab Lab.
Yeah, thank you. My name's Caitlin. Thank you for doing this research. I have a question regarding the time, and you mentioned a lot about the time that the workers were creating, and also the materials. So compared to regular construction or a more handmade approach, how did the technology, how did the technology affect the process? So was it more sustainable in terms of, like, did you lower costs or anything like that? Or was this mostly just to experiment with how much, what did your analysis of the data show you? That's what I need. Thank you.
Hi. The principal objective of the project is the design of the joint, because the cost is very much right now in Chile. But
Michelle, la pregunta tiene que ver con el tiempo en comparación entre una obra de concreto y una obra es más rápido, es lo que tienes que contestar.
Si quiere conteste.
Yeah. Well, she didn't understand the question, but it was faster. It was faster in time, much faster, but it was more expensive because it's not common to work with robotics and assisted systems here. The most common contraction here is reinforced concrete, and it is much longer. On the other hand, we had to face the COVID problem, and that took time as well, took extra time, but that was because of the pandemic.
So have you all brainstormed ways to lower costs, or has it been, is there any way within the process that you already have utilized to lower cost? Just curious about those things.
We could lower it if the technology become more massive. But today in Chile, there is like about 500 robots that are doing this type of work. So you can tell, it's very, very little yet. It's a very, very expensive technology. Glue laminated beams are very expensive still in Chile, despite that we are a country that produces timber. Most of our timber go to Japan, to other countries. And most of the contraction in Chile until today, like 70% is reinforced concrete. This is because of seismic reasons and because of cultural reasons, because wood is normally taken as a light material, not a solid contraction. So today is a new Chile for 2025, Chile want to make a shift into timber contraction and medium high timber contraction, as it is in Canada, for instance. So yeah, we are moving towards there because of sustainability and because we are a timber productive country, so. And it is less expensive when you don't use robots. When you just use the wood like the regular way, it is less expensive compared to reinforced concrete, much less expensive, like I would say like 6% less. Yeah.
Excellent. Hey, thank you both, Michelle and Nina, for the paper, the excellent paper and the feedback.
Thank you.
So everyone, thank you. Let's move on now. I do believe that Ju Barros is ready to present the paper from Belo Horizonte in Brazil called Digital Biofabrication, Sound Architecture and Mycelium.
Hi, Cindy. Hi, Peter. Hi, everyone. I will share my screen. Okay.
Yes.
So this paper is A
We
digital
don't see
fabrication.
we don't see the full slide.
No,
No,
my screen, all the screen, no?
we see your window.
Sorry.
Ju, você tem que colocar na apresentação, lá na tela, lá do lado em cima tem quando você colocar em tela cheia a apresentação.
Não, mas no mural não tem jeito, Jaque.
Eu acho que tem, eu vi um símbolo de apresentar lá em cima.
Não, mas se você aperta a apresentação, ele conta. Peraí, deixa eu ver aqui. Não necessariamente ele não precisa. Ah, tá. Ah. Tá, tudo bem. Deixa eu ver, mas é porque acho que não está aparecendo toda a minha coisa aqui. Peraí. Now?
Same as before, we see your browser window. We
But
see, it wouldn't be a problem, but we see only half the slide, I think. Can you make it full screen? Presenter view?
Are you seeing the title of the paper? No?
We see the
Here,
title of the paper, yeah.
okay? But it's a board, okay? I will present a board.
Okay,
Okay. So the title is Digital Fabrication, Sound Architecture in Sicília. We are from Belo Horizonte, Minas Gerais, in Brazil, from Newton Paiva, University Center of Newton Paiva, and architecture and urbanism course and pharmacy course in the Fab Lab Newton, right? So here we are, me, Juliana, Jaqueline Leite, Carla Queiroga, Alessandra Duarte, and Lanai, Rafael, Juliana, Tamara, and Victoria, okay? So a global change is the way we produce and consume applies a rapid revolution of production systems. And just like the revolution brought about by the personal computer and the internet, digital manufacturing technologies have initiated radical transformation in industry and consequently in a global production and consumption in the last decade. So Fab Labs have become important players in this transition. The experience with the Fab Lab Newton brought to light a problem common to all digital fabrication labs: the use of highly polluting raw materials and poor waste management. In 2018, Fab Lab Newton became a partner with the city of Belo Horizonte in a Fab City Belo Horizonte project. And the challenge of the Fab City Belo Horizonte is to make the city fully sustainable, self-sufficient, locally productive, and globally connected by building a network of partners. So since then, the principles of here, our Fab Lab and in the Fab City have been applied in the daily life of the lab, especially regarding the disposal of materials. So the COVID pandemic awakened us the urgency to make the practice proposed by the circular economy and the democratization of digital manufacturing technologies faster and more accessible. So these factors, coupled with the mapping of local resources for sustainable production of bioproducts, constitute the appropriate ecosystem for us to ask the question, instead of transforming, producing, and discarding, can we grow products? And our starting point is a fungi and mycelium. As you all know, fungi are a natural, renewable source of structural polymers and high reproducibility, low toxicity, have a sustainable life cycle, and is biodegradable. So fungal cell walls are presented in E5, which together form a fibrous and very strong network called mycelium. The mycelium grows using a substrate as food, and in our case, appropriates us to reuse the agricultural waste, making the production process sustainable, of low energy consumption and ecologically beneficial. We can use a lot of substrates: cereals, straws, dried grass, foliage, sawdust, corn production waste, and a lot of, among many others. So the process of the production by mycelium based biocomposites starts from the select of the substrate to be adopted and the species. It is possible to develop fully sustainable mycelium-based products for use and input in digital manufacturing technologies from agricultural surplus, creating a circular production chain that benefits fair trade and promotes local development. So biocomposite with mycelium is really alternative in substitution to petroleum-based materials. And people, in this moment, people are the world is going through a constant change and a resignification of life standards. According to the World Health Organization, noise pollution, along with air pollution from gases emission and water pollutions are the three ecological priorities. So excessive noises seriously harms human health and interferes with people's daily activities. So it's necessary to contribute in the improvement to these conditions in order to limit and control the exposure to environment noise, seeking better planning, efficient building system, and material grade acoustics performance. And mycelium is have shown about a lot of researches that is an alternative as a substitute for hydrocarbonate products such PU forms. So our goal, our objective, the objective of this paper is to present the process of defining an open source design methodology and the current stage of the research for the production of mycelium-based composites for acoustic applications. So the methodology of the production is here. The picture illustrates all the process and demonstrates the entire production chain based on a concept of circular economy. So the purple cycles here represents the process carried out to the moment of the research. As I told before, the process starts from the selection here, from the nature. We select the substrate to be adopted and species. Here is the local resources and tests, and the species, especially the genus Pleurotus. Substrates here are especially agricultural waste and MDF and sawdust from our Fab Lab here, then the Belo Horizonte Fab Lab in Newton. So the mushroom species are here, as I told you. As the productive, as a bioproduct, the create process here starts with the species, the feedstock, and the cultivation here with humidity, controlled temperature, and they start growing. And we start here the fabrication, the prototype, it's represented here, the 3D modeling, and we start the printing of this model, and here's represented for the vacuum PETG model, the model in vacuum in the model of PETG. So then we form it, and we are here at this moment. We are producing to the hydration and goes to biomaterial. So the application and the end of the life of the material returns to nature. So the conclusion here, this article concludes that on the possibilities of integrating biomimicry into design, computational technology, and synthetic biology for the production of efficient and environment-friendly materials at low cost as alternative for the market. So this research is under development to create the process to defining the methodology for biomanufacturing of mycelium-based material. Open source. Thanks.
Yay, well done, Ju. Thank you. Super interesting. I can open it up to questions if anybody wants to just pop your mic open and ask, or put, I don't see any questions in the chat. If there's no other questions, I'm just wondering how large, if these are acoustic panels for room, how large are you able to do it so far?
About 20 centimeters.
Okay.
Like this.
Yeah.
Okay.
So hopefully maybe you can go bigger scale.
Yeah, you can use a model, like you can create a panel, a big panel, right? We will, after that, we will measure and test this material to make a characterize them and verify their properties of sound and thermal absorption, and density and mechanical properties and water absorption, like this.
Yeah, okay. So, and Carla is adding, we intend to create modular designs. Aristarco from Puebla says that in Egypt, someone presented something similar, but they used mold pressure to form it and to make a very solid material. I suppose there's going to be issues with fire regulations and things like that, that you have to Yes, sometimes these organic materials compared to synthetic have these kinds of trade-offs. But I guess that will be part of your investigation.
Yes, of course.
Excellent. Thank you so much.
Thanks, Edie. Thanks, Peter.
Now we will move on to another paper from various organizations in Belo Horizonte. I know I'm pronouncing that wrong, from Brazil. And I think, is Jacqueline going to present Ecozona 30, Rammed Earth and Digital Fabrication for Urban Regeneration?
Yes.
Excellent.
I'm gonna share my screen. Just 1 second. So thank you, Cindy and Peter, for the opportunity, and thank you all so much to attending here today. My name is Jacqueline Veil. I'm from Brazil. I'm an architect professor at Newton University in Belo Horizonte, and I have a PhD in Earth Architecture. I'll be here presenting today the paper Ecozone 30, Rammed Earth and Digital Fabrication for Urban Regeneration. The authors are Carla Verkaiser, myself, Janaína Dias, Eveline Trevisan, Karina Arimateia, Tiffany França, Ana Carolina Carvalho, and Maria Rosa Barriga. So Belo Horizonte is the capital of Minas Gerais state and the 6th biggest city in Brazil. Regenerating the city has been an important goal in the last 6 decades. The capital was the first planned city of Brazil, and it has built 123 years ago as a symbol from Brazilian urban planning modernity. In 2010, the municipality of Belo Horizonte, through the Transport and Transit Public Enterprise, BH-Trans, launched the first version of Belo Horizonte Sustainable Urban Mobility Plan, named Plan Mob BH. In part, as part of long-term strategy for sustainable mobility called Plan Mob BH, in 2014, the Belo Horizonte municipality, in partnership with German partners Wuppertal Institute and other international and local organizations, implement interventional entitled Zone 30. And the Zone 30 foresees the establishment of local roads with a maximum speed of 30 kilometers per hour for vehicles, giving priority to those who walk, cycle, or have reducing mobility, especially the elderly and children. In 2020, using the same methodology process, the stakeholders implemented the third Zone 30 interventional located in Santa Teresa neighborhood. Being part of the Fab City Belo Horizonte network, BH-Trans invited the Fab City members Fab Lab Newton, which is the academic Fab Lab, and Studio N, which is a school office of the architecture and urbanism course of the University Center Newton Paiva, to develop the sustainable urban furniture for the interventional area of Zone 30. With the challenge of using local material, the furniture has developed in Rammed earth, an ancient vernacular earth construction technique. The earth has been one of the construction materials most used by men since prehistory, both in popular construction and representative buildings and monuments. The Remit Earth furniture, in addition to being a sustainable material for using local material, rescue a technique widely used in colonial Brazil, thus enabling the community to have contact with the raw earth and the culture roots. The opportunity to make the Remit Earth furniture in situ made it possible to suggest position for benches and table in shaded places and desired by the community. In the sense, places were suggested for the elderly to rest and socialize, benches for adults and sit while watching the children, and even a specially placed seat throughout the train pass, which is next to the gates and give visibility to the surface subway line adjacent to the intervention. One of the important and complex steps of the Remit Earth technique is the elaboration and execution of the formwork. This is the formwork that we created in Fab Lab Newton. I'm gonna explain more here in a video. As Remit Earth is an ancient technique using the most diverse regions of the world, it's evident that there are different types of shapes and compactors. Formworks must be resistant to the impact force of the compactor and the pressure exerted by the earth during its compaction. However, despite being well structured, they must be light and easy to operate, as the activities of assembly and disassembly of the form are crucial for productivity. A common way of locking the forms is using metal bars, which, despite being functional, it's difficult to assemble and disassemble. To innovate and make it easier, the shape design was thought so that would be no metal locking. All fittings are made through cutouts made in 22 millimeters plywood and cut by CNC. During the execution of the benches, the forms proved to work well, withstanding the pressure of the soil compactation and being quick to assemble and disassemble. Only the formwork with the central partition did not present good locking, impairing soil compactation and causing failures in the final product. So here in the video, you can see the method of doing Remit Earth and how we assemble and disassemble the formwork. And now you can watch how it's easy to disassemble and make the production very, very fast. We did 3 types of formworks. One is this that have 50 centimeter. It's a square and a cube. And we did another that it's a larger bench and a table. During the 3 days of the proposal physical implementation, the opportunity given to volunteers to make the furniture with their own hands and to understand the process involving its elaboration from the manufacture of the molds, the trace of the dough, and the use of the Remit Earth technique and cure time promoted intense learning and the possibility of integration between the actors. Due to the pandemic, the community couldn't be invited to participate in the execution, but this is a technique that allows the participation of the community although necessary, the supervise of a specialized professional in the area. The Remit earth benches take an average of 1 week to dry and harden. Due to the short delivery time, the installation of the space was not possible, causing small breakage in the furniture. And for the future deployments, an isolation is recommended to avoid use in the days following the execution to avoid such breaks. In the end, 14 modules were executed in 3 days. This rapid production was only possible thanks to the use of FabLab Newton CNC machine. The benches after drying have good resistance and the space is being well used. So this is my conclusion. I thank you, everybody. This is my contact here for further questions. Thank you, Cindy and Peter.
Very good timing as well. Excellent.
Thank you.
I would like to open it up to the audience for questions.
Yeah, if I may, you use this technique now for building those benches. How would that technique? How do I have to imagine that technique would scale up to larger structures?
You mean like in construction of?
Yep.
So you do like holes in the work forms. So when you do the first line and you can fix the formwork up in the first line. It's like you can do like this small formwork, and then the next line. I don't know. Sorry about the names in English technique, but it's like you have to have some holes in the formworks that in the next line you can fix the formworks above. Is it?
Yep. Yeah, I get the idea. Yes, thank you.
Yeah.
So it's also modular.
Or in Brazil, there's some modern construction in Remit earth that they do like metallic structure with already the size of the wall. So you don't have to enable and disable and fix it again. So it's faster.
Thank you.
Is part of your goal to also have it open source so that other communities
Yes.
could do it? So you have the instructions.
Yes. We have to adjust a little bit of the design, because in the field, if we can say, in the production, we saw some issues. So we're gonna remake the design and we are going to make it open source.
Yeah. It would be great if you could somehow track also who else starts to
Yes.
do them in their
Yes.
urban areas.
Will be great.
Have
to
a
do that.
gallery
Yes.
sharing.
Really.
Great, wonderful. Thank you very much.
Thank you.
Thank you, Jacqueline. I know I did see Pamela Zoria, Raul Valesquez in the, yes. Oh, and you.
Yes, hi. We're together.
I believe you are presenting the garments paper.
Yeah.
Okay, so we have a paper from Lima, Peru, with some of the co-authors from FabLab ESAN, and the paper name is Garments Elongation Improvement, the use of digital fabrication technology to develop rotational and re-entering auxetic designs on fabrics. Please go ahead.
Okay, thank you very much.
So yeah, well, our paper is titled Garments Elongation Improvement, the use of digital fabrication technology to develop rotational and re-entering aesthetic design fabrics. This was made on FabLab ESAN and the University of Lima.
Sorry to interrupt. There is something wrong with your screen sharing.
We're seeing only
yeah,
half
it
the
has
slide.
double line.
Pamela, we are seeing the part of it, only a part.
Only
Yes.
half.
Okay. How can we expand? Because yes, we see. Wait a second.
Press the, there you go.
There you go.
Yeah.
Okay, thank you.
It's okay.
Okay.
So at first we saw that fitting on a garment was a really generalized problem because of the proportion of the different bodies we have. We all have unique bodies, and this also varies depending on the geographic zone. This makes fitting a really difficult issue. So now we are supposed to fit on a garment, but this shouldn't happen. We don't have to fit on them. Body changes with time, and we need to start thinking about that. So on the other hand, we had that commercially there are billions of non-sold garments. So billions of dollars are spent on production because sometimes brands make garments that don't fill the needs of the consumers. Sometimes they're also burned, as we see in this picture. This is eliminated as waste. As engineers and also fashion designers, we wanted to solve this problem not just by upcycling or the regular procedures. We wanted to go to one of the cores of sustainability, that was production and also people, because we're thinking about the consumer. So we saw that this technique was applied now in baby garments, but why not applying it on regular garments? So this research began in 2019 with a dress design for a fashion catwalk, but we wanted to make a unique size for all the models because we wanted to fit everyone. Since we did the trial and error in that moment, we switched it to a more scientific perspective. And the technical name of this kind of structures is offsetted structures. This allows the material to be stretched in really particular ways. As we work in the textile industry, we thought this was actually a good idea to start fighting back the problematic we introduced at the beginning. So for the fabric and pattern election, actually the patterns were studied in previous papers. So they look to validate these properties already. This is why we focus on the application of them, but in common use fabrics, because we want it to be replicated. So we had these properties that we consider that are fit, elongation, power, tensile strength, also recovery, because we want the fabric to have pressure and to stabilize, to have a stabilization and support on the surface of the body. Also, this had to be comfortable, and it had to have thermal comfort, because it had to maintain the body regular temperature, and it had to have also a good tactile sensation. So these are the three fabrics we chose for this experiment. The first was taffeta, that's made of nylon. The other one is sweat, that is made of polyester and elastane because of their elongation properties. Tartan, that is made of wool, and the last fabric we actually create by a combination of tartan, that is made of wool, lycra, that is made of nylon, and an adhesive pelon, that is made of polyester and also polyamides. So these were the patterns that we chose. We tested these seven structures because, as I said, of the compression that had to have in the body. So we couldn't use the fabrics that elongate too much or that had like a really uncomfortable feeling. And so we chose on the qualitative analyze, we chose two of them. That is the one that says X, that is the final one, and the one that says 3, that it can be seen on the left side of the screen, because those two had a good development where we elongate them. They, as I said, that they compress good to the body, they don't separate it too much, and but well, for the quantitative part, we just chose one that was the third one, because X or 10 had a good development, but wasn't as good as the other one. Oh, okay, sorry. So yeah, as I said, well, those are the photos of the structures being opened. And we also considered the fragility and the resistance to manipulation. This is why we made the experiment that we will see that Ro will expose. And yeah, that's
Okay. So we found the best behaving pattern, which was the third one, and we selected because it will limit or we had a limited number of tests we could do. So we had to test which real numbers, which how much the pattern can stress and how much it can elongate. Since the research is about elongation fabrics. So as Pamela said, we tested a rigid fabric, which was the taffeta, an elastic, and a semi-rigid fabric, which were the thread and the compound fabric. Each one with the laser cutted. We used a tensometer to stretch the samples, and found well, first the samples were like, really easily pulled until they duplicated their size. It was like the most exciting part. And the second was the direction of the pattern the increases or the elongation of the percentage or the tensile strength used in the test. Well, speaking of the elongation, all the fabrics have similar behaviors and shattered just a little after reaching the max elongation point in the main direction of the pattern. It happened because as the strip was stretching, the pattern started deforming and let the strip keep stretching until the point that the connection points were holding the structure. It can be see like here. The pattern will start deformating as I said. And well, on the graphic we can see the deformation this up and down in the graphic in the left. There are every deformation point of each one of these cuts. Then the tensile strength of each fabric has like interesting results. Being the thread, in the elastic one, the one with an unexpected result. As we can see, the tensile strength on the cross direction was like increased a lot in the rigid and semi-rigid fabric, but in the elastic fabric, there was even less force needed for the elongation than the main direction, which was supposed to be the easy one. Well, this is conclusions. The study pattern has proven to be really stretchable in the desired direction, to be more resistant and to be more resistant in the cross direction as expected. As I told before, we had more than 100% of the mobility. However, this information reaches the limit between technicality and reality usage, because as the picture shows, at some point of elongation, the fabric couldn't be used in a real garment. Besides, independently of the kind of pattern used, the test revealed that material can be strongly influenced by the material used. Because, well, as I said, the elastic fabric was like had an unexpected results comparing with the rigid ones. This experiment has proven that using the modern technologies like digital fabrication can greatly help in the development of new materials by upgrading the existing ones.
So for future researches, we saw that excited property has limits that is to be explored, so they can be used properly, because on the cross axis where you had to expand, as we saw on the thread, there are fabrics that actually have a different behavior. So we will have to see why this happens, because that was really unexpected. Then on the other hand, deeper exploration of oxidic patterns and structures need to be done, not just in, well, we're starting in fabrics, but in other materials also. We need to continue the research of the uses of oxidic structures in fashion industry, as I said, also in a virtual way because of this kind of context of pandemic. Just in time.
Well done. Nicely timed.
Thank you.
So I can again open the floor for any questions. I do have one myself. You presenters have a lot of fans in this research audience today. Can you tell me a little bit more about from the fashion and clothing design point of view, what is the added value of these kinds of structures? What are the kind of characteristics? Is it just expressive, or what would a fashion designer gain from these, using these kinds of patterns?
Yeah, actually, well, it's expressive because of the different structures and the meaning that can have each one. But it's also functional because as we see in these pictures, well, I don't know if it can be seen, but we use an oxidic pattern in the skirt. So this was used by a woman that was, I don't know, size maybe 42 or 44, and also by one that was using 38 size. So because we wanted, as we said, we wanted to be fitted on any kind of body. We proved this on my mom, we proved this on me, and also on the model. So it has a functional way of improving the development of the garment itself, because we can in fashion design or in pattern making, it's quite difficult to do this part of here because it has a lot of tension, the part under the arm. So if we apply these kind of structures, any garment can be fit on any kind of body because this will stretch, will elongate.
Would mold to each body.
Exactly, yes. So that's a functional part, yes.
Okay, interesting. So when I have my fat day, this is perfect. When I have my fat day.
Yeah. We all have those days. Yes,
Yeah,
but,
exactly.
yeah.
And then after I have a few days of salad and water, then I'm back down to normal size. And
But this will fit perfectly anytime, don't worry.
Fantastic. Interesting exploration. Thank you very much. If there is time for one more question, if anybody would have anything. I don't see any hands up, or you can just unmute yourself and go ahead. No, I think
it would be, sorry, it would be interesting to see heavier weight materials be cut in this way, to see like on a sculptural scale, or even just for garments, to see how it hangs. I was thinking about bag straps, or maybe even, I don't know, like really heavy felt. Who knows?
Really heavy felt stretched across a room like a room divider. Very
maybe.
Yeah, well, we're trying to develop a new material. Not have fashion is our core research, but as a new material, it could be used in many ways. That our goal right now is like to use it in the fashion market,
right?
Use it
yes,
in other industries too.
Yeah, we know that it's used on aeronautics right now, but maybe we can just apply it to any kind of industry, because we also have the problem of space in the cities, because we are just, there are a lot of people, so we can use products made with oxidic patterns that maybe can be just reduced size. So yeah, we don't know. We have an infinite field of exploration here.
Excellent. Thank you very much. Well done.
Thank you.
So we are going very well with our time, and I have seen Antonio in the participant list, and she is the first author of a collection of authors, including some from Fab Lab Astral, all from Chile. And the name of their paper will be Sustainable Design, a tool for the valorization of natural heritage value areas in the southernmost town in Astral, Patagonia, Chile. So Antonia, the floor is yours.
Thank you. I will now share my screen. Mhm. Do you see the screen or like full screen?
Yes, perfect.
Okay. I will move this over to here. Okay, thank you. First of all, good afternoon, and thanks so much for the recognition of our work. My name is Antonia Valencia, and I'm the coordinator of Fab Lab Austral, located in Puerto Williams, Chile, and it's the southernmost Fab Lab in the world. We want to talk about a change of perspective and locating Puerto Williams in the summit of America. And now, instead of looking from the south, from the bottom of the world, we want to start talking about from the top, a literal change in perspective. And now, instead of we look from the south to down, this change is also about the change of perspective about a sustainable development where the biosphere reserve is located. So this is a spot of high condensation of natural mosses and plants. So now with this new way of looking at it is the way that we approach this new design of a new material. So talking about that, we start in Cape Horn. This recognized in 2005 by the UNESCO of the value of the unique resources and biocultural heritage. It has over 50% of species of endemism of biophytes and lichen of the biodiversity. And it also counts with 3 national parks, including forests, wetlands, glaciers, and an extensive coastal shoreline. So this is a very rich area of biodiversity. And it's a point that is always present in how we approach this area of valorization. So this territory is characterized by hosting the subantarctic template forest, and that has been identified as one of the most pristine ecoregions in the whole world. Its uniqueness has to do with this biodiversity of the stream south of America. And it's also at the last chain. So worldwide, it has a high dependency of the rest of the world, high dependency even from our own territory of Chile. So it's very separate, it's very still pristine, it hasn't been touched. So that has lots of good parts and some very hard, difficult process in how we as the community have the how do you say, the links with the rest of the country and the world. And so also the current environmental crisis is a call to move from the method centered of individuals to one oriented more of an ecosystem. It emphasizes the collaboration and the cooperation. So this new paradigm of the ecological translations or transitions to change to something more sustainable involves the intrinsical and local characteristics, elements, geographical conditions, and the territory. So we have this challenge to value and to protect the ecosystems that surround us. Now there's a little video. Just to enter in a context, Puerto Williams is located in the Navarino Island, south of Tierra del Fuego at the end of the supply chain, how I said before. Its city is inserted in a green area of natural, surrounded by wetlands on an island of the southernmost city of the world. 36% of the island has to do with sphagnum bogs, moss ecosystems, and flooded with water. It's 300 kilometers from the nearest city in Punta Arenas. So this is an opportunity for the project to seek to use tools and design process to be applied to move to something more sustainable life, links with the community, and to be aware of where it's situated, or where it's that ecological environmental impact. So this is like a coexistence and collaboration between species and also the community. Also, how do I move this? And also so that you should know, the only way to get to Puerto Williams is by a boat or a plane from Punta Arenas. This is a low capacity plane, and it's 300 kilometers. The only way to have people, to have the food and anything enter is do a course of 32 hours, only once a week in this boat that you see in this image. So it mobilizes people, supplies, groceries, and so the island, that's the only way of transporting it. So there's a lot of challenges living in the southernmost city of the world. With all that said, these challenges open the need to take care, to value, to educate, and to promote restoration and to look after this pristine territory. So there's challenges of the future with a sustainable projection. So a multidisciplinary team of investigators in the area of biology, education, and design took this challenge to embark a transdisciplinary work with local networks operating in Puerto Williams, including the Universidad de Magallanes, Universidad Católica, and Fab Lab Austral, with specialists in flora and fauna for this biodiversity conservation. So we have this challenge in the area of the design in the biology aspect that's around us. So in this work, we disclosed this approach to conceal an intervention in the public spaces, combining local capacities, unsustainable design, and biodiversity, about the miniature forest, and that most of the time has been invisibilized. And this called out our attention since they're very small, but they are diverse and essential for the island. So this intervention is meant to foster the knowledge of native bryophytes and lichens, closing this gap between the nature and the society in the remote island of Patagonia. And it also consists of the development of experimental prototypes to establish local microhabitats for environmental education and scientific research, with the emphasis in the conservation in the Magellanic biodiversity in Puerto Williams. And natural form shows us and invites us to stop manipulating the factors of this biosphere and to put it in value and to include it into a design process. So also the notion of the distributed system of the digital fabrication of this new social revolution proposes like a rejection of the centralized systems from a production method and goes into a more distributed way of production and using the local supplies of the ecosystems into the design process. So this is where an experimental methodology starts. It proposes to do a cyclical iteration of the design process to establish a loop and improve itself. And it's made up of 4 segments, each dependent of the previous one. The first one is with the investigative process to interpret it into that solution. So the objective is the formation of an habitat of a species that can survive in the city of Puerto Williams. And it should be noted that each particular geography has an ideal climatic condition, and therefore the conditions are very according to the species that has to be treated and the climate geographical location where they're found. The process of the cultivation of the moss has very intense part of the biology, part of the team, and it was the cultivation of this moss and the observation that we have from the island. And then we go to the material experimentation that speaks to the iteration process for the construction of the raw earth. And the objective is not to find methods to prototype structure of the moss species, but to manufacture and disseminate. So the first part is creative cycle, response to the first test to understand the properties of the materials. And then we incorporate different moss found in Williams, and the different frequencies of the nutritive mediums were studied, how the mix of the moss and the soil. And then we went to the form. So after defining this maturability, the proportions and the formulas with the construction, we were subjected to the variant size, special formations, and integrate into the environment act as the mother structure. And last, about the results, we worked with maintaining the idea to nurse a sculptural character of the confection, since we had a block of the raw earth, and injecting with different applications of the moss. These are some first approximations of the Fab Lab. That here you see a Fab Lab Australis mission is to create a community around the making and prototyping sustainably and collaboratively, based with local resources and the knowledge. And the fact here is that we plan to do different activations with the community and using this local resources for the valorization and recovery of the urban and natural spaces found in the island. Thank you so much. And this experience does not only stay in Puerto Williams, but it can be something for the rest of the world.
Fantastic, thank you. And now it's time to open it up for questions. If anyone has. I see that Philippe has his hand raised. Please go ahead.
Yeah. Hi. Hola, Antonia. Congratulations for the presentation. I'd like to know whether you've seen patterns of repair and reuse and maintenance, and how relevant they are in what you're trying to do there. Because I assume that being on an island, maintenance is critical. And if you have any other comments about that.
I'm sorry, I heard a little bit far. Could you please repeat the question?
Yeah, I was asking about practices of repair and maintenance, and how relevant they are being on an island, and how critical they are to cultural patterns of use and reuse of materials, and how that impacts on the world.
Being on an island is always a challenge because, as I said in the presentation, you are very far away from anything on the supply chain, or if you have like any difficulties, it's very hard to make it get to Puerto Williams. So in the question, if I understood correctly, was how hard is it to do that, like a maintenance of those of the machines
and how in general, how important is repair and reuse and maintenance in everyday life, in island?
In what?
In
island
life. Yeah,
the fact is that once a week there is a boat that arrives, and that's the whole challenge, because you have to organize everything according to that, and the maintenance of the whole island depends on the whole globalization around the Fab Lab. So that's why we try to use the most local resources, so that maintenance and use of the globalization doesn't affect us. But it's also a gradual change. It's something that's not that easy. So it's something that challenges in Puerto Williams.
I see also somehow the very sensitive and slow design research process that you have, that you presented, is it's somehow repair and care and maintenance just itself, because it's not quick design, it's not like clean slate, new standard materials kind of thing.
No,
And
it's a whole process actually of understanding. For example, in this case, the moss, the soil, it's understanding from all the process of design, understanding about the living environmental characteristics of the materials that we create. And it also is an opportunity to include the community in those process of valorization, of understanding, of using its territory and providing of all that research and all that like knowledge that we have from the local island.
right, fantastic, very, very interesting. I think I would like to now thank all 5 paper authors and presentations and the excellent audience. To sum up, now this week on Monday, we had Fab Lab self-evaluation for impact papers. On Tuesday, we had learning papers and innovation papers. Today, materiality and environmentalism. And yesterday we had a short 1-hour slot during the live Fab TV session, where we also had several of our paper authors give a bit of a summary of their research. So it's been a really fantastic experience from my point of view. I also really want to thank all of you paper authors for being able to react so quickly, since we didn't even have our time slots in the schedule until last week. So thank you, paper authors, for being flexible and being able to join. And I would like to turn it over to Peter. Any final words?
Same from me. Thank you very, very much for this exciting experience at this virtual conference from all corners of the world, the farthest south and the north and the east and the west, and where they meet. And we all meet here online. So thank you very much. And I think I play just this one again.
Fantastic. Excellent. Thank you all, and enjoy the rest of the conference and the Fab City Summit.
Thank you all. Bye-bye.
Thank you. Bye.
Antonia is asking where we can find this recorded session.
We don't know yet, but it's probably going through live.fablabs.io.
Good, good.
Well done. Well done. Well done.
Oh, did I forget to put Antonia's paper link in the chat?
You can still do that for the guys who are hanging around.
Good. I'm also very pleased that we had lots of audience. And happy with the participation and people coming. Yay, good. See you. Yeah, I can't hear you, Peter, but that's okay.
Now you can hear me. You got a beer for tonight?
No, I forgot to buy beer again. I got so wrapped up in other things, so
Oh, yeah.
I have to find something else in the cupboards.
All right.